Hi, this is the first video of this new channel, the RF Noob. And so a very quick presentation. I'm just an amateur in this field, so radio, RF, electronics in general. I'm learning and during this period of forced stay at home for the coronavirus, I've decided to start this channel to share a little bit my experiments, my discoveries. In these days I have quite some time to invest on these things. So, of course, my native language is not English. I'm Italian, so perhaps I will also make some videos in Italian. But yeah, in order to share this material to the wider possible audience, I'm trying to speak in English here. So, okay, here today I want to talk about the HackRF, which is this device here, and its potential to be used as a spectrum analyzer, as I will discuss later. So the HackRF is of course a software-defined radio. I say of course because it's very popular, so you can find a lot of material online and very many videos that show how this device can be used as a radio. So basically you attach an antenna to it, this thing, and the HackRF provide an interface between an antenna and your computer through a USB cable. So in fact this is an HackRF with some kind of you see external interface. This is called the Portapack, and but really the HackRF, the basic HackRF does not have any manual interface. You can communicate and work with the HackRF only through the computer through the USB connection. So let me now show you what really is the HackRF without the Portapack extension. So you just remove this cover here. This is the Portapack extension on this board you plug on top of the HackRF. So let me remove it kind of carefully. I don't want, well, more or less. So yes, this is the Portapack extension. It provides, you know, some very basic functionality. So an interface with a display and buttons here, an audio and microphone interface, a battery and SD card reader. So the idea is to allow some form of interaction from the outside to the HackRF without the need of a computer. But yeah, so for this video I will not talk about this interface, this external Portapack extension. I will just focus on the HackRF, which is this thing here. So yes, this is the basic device. It's very nice, and it costs. The nice thing is that it costs from China, AliExpress, only about $100, 100 euros. So I paid 100 euros. I mean, I paid 150 euros. So for the two things here. But you can find just the HackRF with its own aluminum cover for about 100 euros. So it's a very popular device. So the interesting fact, it's quite amazing, is that this device can both receive, like many other software-defined radios, but also transmit. So this has the potential to be a half duplex transmitter. So it cannot receive and transmit at the same time. It can only do one thing, so that's half duplex. But still, it's very interesting due to its low cost. And also another interesting thing is that it can receive and transmit from 1 megahertz to 6 gigahertz, which is an enormous amount of spectrum. And so this is of course very interesting. So one application, one potential application of this is to be used not just as a software-defined radio, but as a spectrum analyzer. So let me show you what a real spectrum analyzer is, and so later we will discuss about using the HackRF as a spectrum analyzer. So here you can see my HP 8591E spectrum analyzer. So this is a rather old instrument, so it's about 30 years old, but is just amazing. I bought it very recently on the second-hand market for a very good price, so I'm extremely happy about this spectrum analyzer. It can go from 9 kilohertz to 1.8 gigahertz. So in this respect is much less of what the HackRF can do. But of course, this is a much more serious and precise instrument. It's calibrated and everything. So I'm going to use this just as a reference to see, at least in the interval 9 kilohertz, 1.8 gigahertz, how it behaves, how a professional instrument like this behaves compared to the HackRF, which is a hobbyist sort of device. So let me just show you quickly what spectrum analyzer, or this spectrum analyzer, does and look like. And so I just turned it on, and so you see the monitor flickering a little bit, but this is just an effect of the camera. It doesn't look like that on the real without the camera. So we're going to use this just for a couple of minutes. Then fortunately this spectrum analyzer has a video output on the back, and that I can use that to connect it directly to my computer. So we will be able to see directly the display here on my computer with a screen capture program. And so we will see the details of this monitor, even if at the moment you cannot see very much. But the point here, I just want to show how this looks, generally speaking. So this is the input, where you connect the source of the waveforms, the signal. And in this case, we are just going to plug in the input an antenna, the same antenna that was previously plugged into the HackRF. So let me connect it and extend it a little bit for some gain. Okay. So now you can see that there are some signals present. So the spectrum analyzer is currently showing the signal from 0, or actually 9 kilohertz, so it's the lowest point, up to 1.8 gigahertz. So this is the type of signal you can see. As you can see, I can press marker here. I don't know if it is visible, but it shows marker 900 megahertz here, because the marker is currently here. It's barely visible with this camera. The focus is not great, but believe me. And anyway, I can move this marker, and it's now moving across the screen. I'm trying to go to this high peak here, and that's at around 99 megahertz. So this is, you see, the center of the broadcast FM band. So that's not surprise that there is a signal there. And the peaks are at in this band, so around 100 megahertz. Then there is a rather strong presence around 221 megahertz. I frankly don't know what that is, but maybe you can tell me in the comments. And there are also two other peaks of quite some strength, and one is at 810. I think this is the 4G connection. I'm not entirely sure. And then 940, which I think is the GSM connections. So again, I might be wrong on this. We'll now connect the video output of the spectrum analyzer to my computer, get a screenshot of this output, so we can have a look at this with some calm, and then see how the HackRF compare to this type of view. Then we will go into some more details and some more sophisticated kind of measurements. So I have connected the output of the spectrum analyzer to my computer, as I said, and this is the result. So we can now have a look at the display of the spectrum analyzer here, which is much easier for you to view. So I'm going to just put this here, I guess, big, or let me see, maybe here, so you can see what I click on the spectrum analyzer. And this is the screen. Okay, so I just want to follow a little bit what I was saying before. So we have these peaks here. So again, let's take a marker, and now the marker is clearly visible at and if you have a look here, it's about 900 megahertz. So the antenna just dropped, but okay, fine. So here you can see 900 megahertz, and the marker is the center, just at the center here. So I can move the marker and around the spectrum, which goes. Okay, the center of the spectrum as written on the. So perhaps it's actually better if I just put the thing here. So you see, the center of the spectrum is written here. It's 900 megahertz, and the span is 1 gigahertz point 8. So this means that at the center here we have 900, and the whole horizontal axis is 1.8 gigahertz long. So basically here we have 0, and here we have 1.8 gigahertz. Okay, so anyway, let me move the marker, and as we already observed before, but I don't know if you managed to see it. Here around 90 megahertz we have 94, we have this very high peak. This is the FM band, and indeed if I set the frequency, so I click frequency on the spectrum analyzer, and now I can set the center frequency to something different than 900 megahertz. I can put for example 98 megahertz, and I then set the span to just 20 megahertz. And there you go. So this is what the spectrum analyzer sees when centered at 98 megahertz and having a span, so the whole x-axis of 20 megahertz. So this is the whole broadcast FM spectrum. So as you can see, moving the marker around, we have several peaks, and each of these peaks is a channel, is a radio station in my area. Okay, so let's go back to our frequency of 900 megahertz with a span of 1.8 gigahertz, so where we were at the beginning. And so I say that we have also rather big peaks at 221 megahertz, something here around 396, and what is this, 495, and then yes, these are I think related to the 4G 105 megahertz, and here are 940 megahertz. It should be the GSM. So the spectrum analyzer can only reach 1.8 gigahertz, so unfortunately I cannot see the 2.4 gigahertz band where my Wi-Fi signal would be, or the 5.8 where the new kind of Wi-Fi signals are. So anyway, this is what we can see from the spectrum analyzer. So this is what a good view of the spectrum is read from a professional spectrum analyzer. By professional I mean something well calibrated and serious. So I'm just going to take a screenshot of this, and then we will see how this compares to the HackRF. So okay, now as you can see, I removed the antenna from the spectrum analyzer, and I connected it to the HackRF. On the spectrum analyzer, however, I still have a screenshot of the spectrum analysis that we just did before. And this screenshot is quite useful because I can still move the marker around, okay? So we can have a look at the spectrum here that we had 1 second ago. This is just a screenshot of what was registered before. So now we have the HackRF connected to the computer through USB, the antenna is plugged. So I can check that everything works fine here by executing, this is Ubuntu of course, Linux, and I can execute the command HackRF info. So everything is working fine, and you can see here is the part number of my HackRF, the firmware was updated in 2017, and everything is working fine. So now it's time to do something with the HackRF, and okay, the main functionality of the HackRF is of course as a software-defined radio to, you know, listen, for example, we could listen to ham radio or many of these things, but the purpose of this video is to see what the HackRF can do as a spectrum analyzer. And for this there is a program called Q Spectrum Analyzer here, which I'm going to open right now. And so let me reduce its size so we can stay here and we can see everything at the same time. Okay, so the Q spectrum analyzer is set to sweep the spectrum, so to observe the spectrum from 1 megahertz to 6 gigahertz currently. So let me just put 1 gigahertz 800 megahertz, so exactly as we had before on the HP spectrum analyzer. And I can just start. And it works. It works quite fine. And as you can see, it's finding a lot of energy, so a strong signal here at around here. We can read the frequency where my mouse is, so when I put my mouse on this very large peak, I get my FM band 92 97 megahertz. So this corresponds on the spectrum analyzer at this very high peak here, right? 99, 90 something. Then we also have these two peaks here, quite visible on the waterfall, but also here. So one is at about 175 megahertz. So let's see if this exists on the HP. Yes, it's this peak here, 185, more or less. And we have another signal here at 218, about 218. So let me have a look. 221. Yes, so you can see it's very reliable. It finds this it's quite visible on the waterfall display here. It's here, so about 800 and something megahertz, and this is indeed this peak here on the HP 801. And then there is this other area of activity around 940 megahertz, which is around here on the HP spectrum analyzer. So we could say that this HackRF works pretty damn well for as a spectrum analyzer, at least to have a qualitative idea of what's going on in the spectrum. There is a problem, I mean, a relative small problem here. The HackRF says that there exists something at 1.2 gigahertz, and this is just not the case here, as we can check on the HP. There is nothing. So this is in fact an artifact of the HackRF. Probably there is some clock inside, there is some noise inside the HackRF generating this artifact at 1.2. So at the moment I'm showing the main curve as well as the max hold. Another interesting thing would be to take the average instead. So this shows things in a much more stable way. And we can see our peaks. Again, these peaks is completely imaginary. It's an artifact. But the others are quite precise. So here we are distinguishing about energy present at 918, but not at 925. So the resolution here is really, really good for what the HackRF is, and it's a 100 euros device, including the aluminum box. So it's really good. And in fact, the HackRF can even go much higher. As we said, it can reach 6 gigahertz. So let's stop this analysis at the moment and start again, stopping only at 6 gigahertz. So going well beyond what the HP can do. So let me start it, and we're going to see here the average. And okay, so this part was basically what we could see earlier, up to 1.8. And but now we can also see a larger portion of the spectrum. For example, there is some signals that it says around 5.15 gigahertz. Well, I don't know what that is, to be honest. This is 5.9. I thought the Wi-Fi was 5.8, so I'm a bit surprised here. We get something around 400. I don't know how accurate is that. I cannot really verify with HP, which give us some trustable reference. But okay, at least we can find some activity on the 2.4 gigahertz. I don't know. So I don't know how much I trust this read of this part of the spectrum, to be honest. So I would need some more. I don't know, some comparison with some other instrument who can have a look at this part of the spectrum, and we'll see what I can do in the future. So if somebody else can has a spectrum analyzer with a higher frequency, up to 6 gigahertz. Maybe you can do the test and report the results, but I don't know if I trust so much this part. Anyway, the part from 0 to 1.8 was quite correct, beside this artifact at 1.2. So perhaps this is also realistic. I don't know. So yeah, I just want to conclude now this video saying that there will be another part where I use the tracking generator of the spectrum analyzer to measure how precise is the HackRF in terms of readings. So for example, here it says that the strength of the signal at 900 megahertz, it's about, I don't know, here it says minus 50 something dB. dB what exactly? It's not clear if this is dBm or it's a relative form of strength of the signal or something. So with the tracking generator it will be possible to verify that with some accuracy. So we will do that, but in another video. So it's for this video is everything, and this was the first video of this channel. So if you liked it, please leave a comment or push the like button or subscribe, and I will see you again.